Hi grade 10s and welcome to this video. In this video, we will be working on the Mathematics Paper 2 for June 2023, and this is specifically from the Gauteng province. Okay, so the time allocated to this paper is 1 hour and it is worth 50 marks. Moving on to the instructions, there are a total of 4 questions in this exam paper. Make sure to round off your answers to 2 decimal places unless stated otherwise. And lastly, note that the diagrams are not necessarily drawn to scale. Okay, so with that being said, let's move on to question 1. Question 1.1 says, if A is equal to 38.6 degrees and B is equal to 141.4 degrees, determine the following. Okay, so we have to find the value of cos 2a, but remember what a is. It is 38.6 degrees, and then we say minus sine, and we have a half, and then you see that b is right next to it, so it's multiplying. You can say multiplied or use brackets, that's also fine. So multiply by 141.4 degrees. Okay, so we just have to find the value of this. So the value of cos, and we have 2 times this. Okay, so 38.6. So you can take 38 times 2 first. And 38 times 2, that's going to be 60 plus 16, which is 76. And then 0.6 times 2, that is 1.2. Okay, because 6 and then 12. So then 1.2, it's going to be cos, and in the bracket we're going to have 77 because we are adding. Okay, so 0.2. And then we have minus sine. And what is a half of 141.4? Well, I'll just separate it into 140 and 1.4. So if you half that, okay, divided by 2, you get 70 degrees. Divide that by 2, you get 0.7 because it's like 14 divided by 2. So we're going to have 70.7. Of course, these are also just angles, degrees. Okay, so this is what we need to find the value of. Let's go ahead and punch this in first and get that value. Now remember, this is just cos 77. Don't press shift here at this point, okay? So we are using it on an angle. So we're going to have 0.22154. I'm not rounding off yet, okay? Then minus, and let's get the value of sine 70.7 degrees. And that is 0.9438, okay? And finally get the final answer. So I'm not going to round off, so let's just go ahead and use this, which is weird that, this has been put down. But I mean, this is for 3 marks. Okay, so on your calculator, just make sure you go ahead and punch in cos 77.2 and then say minus, and then this is what we have. Okay, so this is equal to negative 0. And I'll just round off to 2 decimal places because they didn't really say anything about that here. So let's leave that as 7.2. And that is our answer. Okay, this is not degrees. Once you put the angle in, this is the value of the cos function at this angle. Okay, so you're thinking about it like, this is my cos graph. If I go to 77.2 degrees, which is about here, right? We're just saying the value, the y value of the cos graph is equal to that. Okay, since this is 0 degrees and then that's 90 degrees. Okay, so that is the value of it. It's about 0.22154 and so on. Okay, so that is our answer. Moving on to the next question. Question 1.2 says, calculate theta where theta is greater than or equal to 0 degrees but less than or equal to 90 degrees. And we're going to round off to 1 decimal place. Okay, so just remember that. So these are equations, but remember, these are finding the value of theta in these equations where theta is in the first quadrant. So you don't have to consider any other angle. All our angles are going to be acute, greater than 0 degrees, but less than 90 degrees. Okay, so let's go. We have sine 2 theta equals 0.4. And then we can go ahead and try to get to theta because that's what we're trying to solve for. So yes, the 2 is in the way, but it's not really a problem right now. The sine is more of a problem. We need to get rid of that. So to get rid of sine, you can think about it like transposing it. So when it comes over, it will become the second function of sine. And on your calculator, you activate this by pressing shift and sine. And so it will look like this. Okay, and you're going to just go ahead and substitute 0.4 in there. So we'll find out what the value of that is. So all that would be left would be the 2 theta. And let's go ahead and put this on the calculator. So we'll say shift sine and then 0.4. And you see what we get? We get 23 point. Now when you do this, it's going to give you the value of the angle, okay? Because this time you're saying sine 2 theta is equal to 0.4. So you have a sine graph, okay, but it's sine 2 theta. And you're really just asking yourself, where is this sine function sine 2 theta equal to 0.4? Where does it have a y value of 0.4, but specifically when theta is greater than or equal to 0 degrees, but less than or equal to 90 degrees? So 0.4 can be somewhere like here, for example, okay? And so do you see that it would have that y value of 0.4 at this angle? Okay, of course, this angle as well, but it doesn't fall within our interval. So I'm just giving you a little backstory on that so you can see where this comes from. It just comes from the sine function itself. Okay, so let's go ahead and get that. We're not really rounding off. We have 5, 7, 8, 1, and this is degrees. Now we need to solve for theta. What is in the way of getting to theta? It would be the 2. So we need to get rid of 2. And so we're going to divide both hand sides by 2. And so you see how that cancels there. But what you do on the one side, you must do on the other side. And that's why we divide by 2 here as well. So theta is equal to, and just take your answer and divide it by 2. And we get 11 point, and they said round off to 1 decimal place. So that second decimal of 8 will round the 7 up to an 8. So 8 degrees, and that is our answer. Moving on to the next question. Question 1.2.2 says, we have 3 sine and theta over 2 minus 20 degrees equals 0.85. Okay, let's go ahead and try to solve for theta. So we're trying to get to theta. What is the first thing stopping us from getting to theta? Of course, we have a 2, but you see how that, it forms one term with the theta. And then you could look at the minus 20 degrees and say that's a problem. But you see that we can't really get into that yet. We would have to get rid of what is outside. So we'll look at the sine. But then there's a 3 in front of it first. So this is what needs to leave first. Now this 3 is multiplied to the sine and then all of that, right? So we need to get rid of it by dividing by 3. But what you do on one side, you must do on the other side. So that cancels. And now we have sine and we have theta over 2 minus 20 degrees is equal to, and we can't find the value of this. This is 0.85 divided by 3. Okay, so it gives us 17 over 60. Now, how do we get to theta? We can get to it by getting rid of the sine. Okay, so we get rid of everything from the outside first and then getting into theta. So again, how do we get rid of sine? You're going to transpose it and it becomes the inverse of sine. So we have theta over 2 minus 20 degrees is equal to, and on your calculator, you activate this by pressing shift and then sine, and we have 17 over 60. And that is, remember, when you say shift sine, it's going to give you the value of an angle, okay? Because we're saying sine of this equals this. So at what angle is this sine function equal to? 17 over 60. Okay, so that is 16 point. And I'm not going to round off yet because there's a divider by 2. So that will definitely affect your decimals. So leave it as 4592 and I'll leave that. Okay, now how do we get to theta? You see that the minus 20 degrees is in the way. So we need to transpose it. So we have theta over 2 and that goes over to become a plus 20 degrees over here. So it will add to this, making that 36.4592 degrees. Okay, so make sure you apply that here, plus 20 degrees. And now we are at the final stage. We need to get to theta. How do we get rid of this 2? Well, it says divided by 2. So to get rid of it, you would multiply by 2. But what you do on one side, you must do on the other side. So finally, theta, because these cancel, is equal to all of this, and just say times 2. Okay, so it is 72 point, round off to 1 decimal place. That second decimal of 1, it is less than 5, so it's going to round down, causing that to just stay as 9. So 72.9 degrees is our answer. Okay, so that is it for that question. Moving on to the next question. Okay, that should be a 1.3 3. So question 1.3 says calculate the following without using a calculator. So 1.3.1, you can see the angles they're using here. They are using special angles. So you can either use your triangles, okay, your special triangles, or you can use that fan method. But there's a method I use and it's called the OHA rule. Now, using the OHA rule, you need to make sure that you use it with the acronym SOHCAHTOA. Okay, so SOHCAHTOA, we're going to have to put that down. Remember, sine is opposite over hypotenuse, and then cos is adjacent over hypotenuse, and tan is TOA, which is opposite over adjacent. And then the OHA rule comes down. So we just say OHA, and then our angles here. So 30 degrees, 60 degrees, 45 degrees, and then we're going to list down our values. So that is 1, 2, 3, 3, 2, 1, and 1, 2, 1. Okay. Then in each row, square root the biggest number. So here it's going to be the 3, here it's going to be the 3, and here it's going to be the 2. And there we go. Okay, so you're going to use the OHA rule with SOHCAHTOA. And so when you see sine squared 45 degrees, this means you're going to find the value of sine 45 degrees, and then this is going to be squared. Okay, so how do we find the value of sine 45 degrees? Well, you know that sine is opposite over the hypotenuse. So we go to the 45-degree row, and we take the opposite side over the hypotenuse side. So that is 1 over the square root of 2 all squared. And then it says minus cos 60 degrees. And so we'll say minus, and what is cos 60 degrees? We'll go to cos, which says adjacent over hypotenuse. So go to the 60-degree row, and we're going to say the adjacent side, which is 1, over the hypotenuse, which is 2. So minus 1 over 2. And all we have to do is simplify this. Okay, so this is equal to, you're going to square the 1, which is 1. And then the root 2 squared, you see how that would break that root, okay? Because this is a square root, that is a square, they're the inverse of each other. They cancel, okay? So that is just 2. So it's a half minus a half, which is equal to 0. And that is our answer. Moving on to the next question. Okay, we're on the last one for question 1 with 1.3.2. We have to find the value of sine 30 degrees and then tan 45 degrees. Okay, using the OHA rule again, sine 30 degrees will go to 30 degrees, and you know sine is opposite over hypotenuse. So that is opposite over hypotenuse. So we know that that gives us 1 over 2, and then raised to the power of tan 45 degrees. That is TOA, opposite over adjacent. So go to 45 degrees, the opposite over the adjacent is 1 over 1, which is just 1. I mean, you can say 1 over 1 just to show them. So anything to the power of 1 stays exactly the same. So our answer here is a half. And that is it for that question. And that is it for question 1. Question 2, 2.1 asks us to draw a neat sketch of the graphs f of x, which is equal to negative sine x, and g of x, which is equal to 1 over 2 cos x, where x is an element of 0 degrees to 360 degrees. Okay, so they've already given us the interval in which we're drawing this. And so we're going to go ahead and draw our y-axis. And then our x-axis is going to go from 0 degrees to 360 degrees. Okay, and I should probably just pull this down here and then make it a bit longer. And I'm going to keep this as 1 and then 2. We won't really need 2, but, you know, for reference sake, we can just leave it there. And so minus 2. Okay. Now, drawing the graph in grade 10 is very important. It's going to be very simple graphs, but this is really going to form your foundation and your understanding of how your trig functions work. Okay, they're very simple to draw. With the sine and cos graph, you really focus on the same set of angles, depending on what the graph looks like. So, with our sine graph, look at what it looks like. It simply just says negative sine x. So it still looks like the mother graph, y equals sine x. They've just added a minus in front of it. So let's just quickly go through what the sine graph normally looks like. Okay, so the sine graph goes from 0 degrees to 360 degrees. And you need to just think about, so we're just looking from 0 to 360 degrees. Of course, it continues infinitely, but let's just look at it within this interval. So with the way the sine graphs, you can just focus on counting your angles in 90 degrees. And you focus on that. When you see that, we simply just have sine x, not sine 2x or sine a half x. As long as there's nothing in front of x, you can focus on the angles 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Then, if the graph just said sine x, right? And so there's an invisible, and let me just rather put it here. So y equals sine x. It means there's an invisible 1 in front of sine. So that would mean that your graph reaches a highest of 1 and a lowest of -1. Okay, maximum of 1, minimum of -1. And then this is what the pattern of the sine graph looks like. If you used your calculator and then you said sine of 0 degrees, right? Just say sine 0. You will see that it will give you a value of 0. So that means the point we have here is 0 degrees and 0. Then if you tried sine 90 degrees, it would give you a value of 1. So that's 90 degrees and 1. And then sine 180 degrees would give you a value of 0. Sine 270 degrees will give you a value of -1. And sine 360 degrees will give you a value of 0. And so your graph looks like this. Okay, and so this is what the sine graph looks like from 0 to 360 degrees. Then this same graph, all it really just does is it continues infinitely. So 360 degrees before this, it will look like that. And then 360 degrees after this, it will still have the same shape. This is what we call one cycle of the sine graph. And this is why we say the period of a sine graph is 360 degrees. Because it takes 360 degrees to create this pattern, and this same pattern continues infinitely. Of course, that is if they didn't restrict it, giving you this interval. But in this case, they did. Okay, so now that we know what the sine graph looks like, what would negative sine x look like? Well, you're taking all these y values, right? Because sine x gives you a specific value, like sine 90 degrees gave us 1. So what would negative sine 90 degrees give you? It would give you -1. So all these y values that we had previously, they get multiplied by -1. Okay, if 0 got multiplied by -1, it gives you 0. If 1, that y value of 1 gets multiplied by -1, it gives you -1. So instead, you'd have 90 degrees and -1. If the y value of 0 here got multiplied by -1, it gives you 0. If the y value here at 270 degrees of -1 got multiplied by -1, it would give you 1. And then if that y value of 0 got multiplied by -1, it gives you 0. So look at what your sine graph ends up looking like that. Okay, so if you ever see a sine graph looking like this, and you can see it goes from 0 to 360 degrees, it just means they change that value in front of sine and they made it negative. And that's why it goes down and then up instead of up and then down. Okay, so I hope that cleared that up, and that's really just how to think about your graphs. Now we can simply just draw it down. Okay, so I'm just going to replicate what I drew there, here, so you can see your graph. Okay, so there's our sine graph. I'll just leave that in red, and then we can just go ahead and call it F. Okay, and now the cos graph. So the cos graph, also a very simple graph. That graph simply looks like this. I'll go ahead and show you the shape first so you can just see that. It goes up and then down and then up. And then that's the shape you should look for with the cos graph if it is a graph that doesn't include any shifts. So by shifts, I just mean something affected to x. So it doesn't say something like x minus 20 degrees or plus something, okay? Then you should look for the shape. If it was shifted, that shape would still be there. It would just be like, something like that. So you should still be able to spot it. So all of these things, you just learn it step by step, understanding it from the simplest way the cos graph looks, which is the mother graph, which is y equals cos x, the graph we're looking at. And then, you can see all the types of manipulations that can be done to this. Like they can decide to say x minus 20 degrees, or they can decide to put a 2x in front of this, and so on. Okay, so looking at it from the original, you see what the graph looks like from 0 degrees to 360 degrees. Again, like the sine graph, this pattern will continue infinitely if it wasn't restricted like it is. Okay, so you'd have this same pattern repeat 360 degrees later and 360 degrees before this. Okay, so like that. And then another thing about this cos graph is you need to look at what is in front of cos. So there's an invisible 1 here, meaning this mother graph will reach a maximum of 1 and a minimum of -1. Now look at what they have in the graph of G. Look at what's going on here. There's a half in front of cos. So instead of reaching a maximum of 1, it's going to reach a maximum of a half and a minimum of -1/2. Okay, it's not negative, it's positive. So our shape of the cos graph stays exactly the same. It just reaches a highest of a half and a lowest of negative half. And we're just going to sketch that down. Okay, so you can just follow along with sketching the cos graph. So we know that it reaches a highest of a half, and at 0 degrees, it has a y value of a half. So there we go, that's where that's going to be. Let's just plot in red, okay. And then at 90 degrees, do you see where it is? It reaches a value of 0, so that's the y value there. Then at 180 degrees, that is where it dips down and reaches negative a half, not negative 1 anymore, because you know that value has been changed. Okay, so negative a half at 180 degrees. And then at 270 degrees, it reaches 0. Okay, so 0 over there. Then 360 degrees, it reaches a y value of a half. So y value of a half here. Yeah, I shouldn't have let this go on till 2. It could have just gone to 1. That was fine. Okay, and now we're just going to connect our red dots. So it should make this pattern. So like that, down, and then back up. Okay, so that is what our cos graph looks like, and we can just label it G. And there we go. Moving on to the next question. The next question, 2.2, says, determine the amplitude of f. So the amplitude of a graph, you'll notice they will ask these questions with sine and cos graphs. The amplitude of a graph is the height of a graph from the middle. So looking at the graph of f, that is our sine graph. If you look for the middle, it's over here. But you don't even have to overthink it. All you have to do is think about the value in front of sine. Okay, so right now it is a negative 1. But you have to take the absolute value of it. So yes, it's a negative 1, but the absolute value of negative 1 is 1. So you're just going to take the positive of that. And you can see that. Okay, so the middle of the graph is here. And so the highest of this graph, you see the highest from the midline is 1. Okay, so that's how high that graph is. It just goes to 1. Okay, nothing beyond that. So our amplitude is simply equal to 1. And that is our answer. Moving on to the next question. 2.3 says, what is the period of g of x? So what is the period of the graph of g? Remember, we kind of spoke about the period and what the period of a graph really is. The original graph, right? This is the cos graph, and the original is y equals cos x. The period of a cos graph is 360 degrees because this is how long it takes the graph to complete a cycle. Okay, this graph just repeats infinitely. 360 degrees later after this, it's going to have this same shape again. And 360 degrees before this, it will have the same shape. That's why your graph just looks like squiggly lines going like that, okay, infinitely. Now, how you determine the cos graph's period is by looking at this function and checking if its angles have been manipulated. So the focus is on the angles. So you're going to focus on what is in front of x. Right now, you can see there's just a 1 in front of x. So it functions like the normal cos graph. Okay, the angles function the same way. If it had a 2, then you have to think about it again. How we find the period is simply by taking the original period. So cos graph has a period of 360 degrees. It takes 360 degrees to complete one cycle, that pattern of the cos graph. And then you take that 360 degrees and you divide it by whatever is in front of the x, which is a 1 here. So it stays 360. But if it was a 2, you'd say 360 degrees divided by 2, and then that will be 180 degrees. Okay, and so on. So we know that the period of this cos graph, the graph of G, is 360 degrees. And that is our answer. Moving on to the next question. Question 2.4 says, for which value or values of x is negative sine x minus cos x equal to 1? Okay, grade 10s, this is the last question. They wouldn't all of a sudden introduce brand new graphs, okay? The graphs will have something to do with the graphs you already had. So look at what they're saying. They said negative sine x, but we know this is the graph of f, okay? Minus sine x is what we already had. So that is this function over here, f. So they're really saying f of x and then minus cos x. And you know that cos x, okay, this is just the original cos graph. Okay, and then they're just subtracting this by the cos graph, the mother graph, not what we have. Okay, so this is not really the graph of G. I'll just put it in a different color. And they're saying when you subtract these graphs, it should give you 1. Okay, we can think about this here and just focus on the fact that they said sine x, right? The graph of f, and then minus the cos graph, mother graph, and then it gives you 1. Okay, so what we can actually do is we can draw this graph, but it'll be very easy to draw. And the reason why is because we already know what this graph looks like. So the original graph, instead of reaching a highest of a half, it will reach a highest of 1, okay, a maximum value of 1. And we can just change the color of it. And now you see that it fits perfectly here, but you need to ensure that it reaches a maximum of 1 and a minimum of -1. So it will be a quick sketch because you already know what the blue one looks like. Okay, now this is the last question, so I'm just going to dim that color so we don't have to focus on it. Let's focus on the red and the purple graph. Where will we take the y values of f and then subtract by the y values of the purple graph, the original cos graph, and then get a y value of 1? Okay, so remember it is f minus this purple. Okay, let me rather make that graph blue so it's just more clear to see. Okay, so those are the two graphs we're looking at. So where will you take the graph of f and then minus by the graph of g, then it gives us a y value of 1. Okay, these will be all the places where the graph of f is above the purple graph. Okay, because then you take the y value of f minus the y value of that graph. Okay, so you can use your ruler and then look all through. One way that you can do this is measure what 1 looks like on your graph. Okay, from 0 to 1, it's going to look something like that, and then you can just measure all through. So we're only going to look for places where we have the graph of the blue graph really above the purple graph. So here, this is definitely one place this would happen because the graph of f would have a y value of 0, and then the cos graph would have a y value of -1 here. So that would be this y value of 0 minus this y value of -1. See, minus -1. And so that gives you 1. So this is the first place this happens at 180 degrees. If you keep moving with your ruler, okay, measuring 1 unit, you see that it doesn't happen all through here, doesn't happen, and then there, again, this is where it happens again. So you take the graph of f minus the purple graph, and you see you're going to get 1. The graph of f has a y value of 1 at 270 degrees minus the purple graph's y value at 270 degrees, which would be 0, which is 1 again. Okay, and then if we keep going, you see it does not happen. We don't have to check this side because we're looking for where the graph of f is above the purple graph, because you must say f minus the purple graph's y values. Okay, so you see that it only happens in 2 places so far. That's it. Okay, and that is it for that question. We're just going to tell them that this happens where x is equal to 180 degrees and where x is equal to 270 degrees. Okay, so what is the value or values of x? This is where x is equal to 180 degrees or where x is equal to 270 degrees, and that is our answer. And that is it for question 2. Question 3 says, study the diagram below and answer the questions that follow. So question 3.1, we have calculate the coordinates of the midpoint of the line segment AB. Okay, so what is the midpoint of this line AB? So to find that, use the midpoint formula, which is x1 plus x2 over 2, and then y1 plus y2 over 2. And we're going to go ahead and substitute. So we can take that as 0.1 and that as 0.2. So the midpoint of line AB would be found by taking the x value of 0.1, which is x1, so 3, plus 1 over 2, and then 9 plus -5 over 2. But of course, when you multiply the positive and negative, it just gives you a -5. And so finally, the midpoint of AB is, that gives us 4 divided by 2, which is 2. And that will also give us 4 divided by 2, which is 2. So it's 2 and 2. Moving on to the next question. Next question is we have to find the gradient of the line AC. Okay, so looking at A and C, I'll take that as 0.1 and 0.2. To find the gradient of a line, we just say M is equal to y2 minus y1 over x2 minus x1. So gradient of AC would be found by taking the second point's y value, which is 3 minus 9. So 3 minus 9 over, and that's -5 minus 3. -5 minus 3, and simplify. So finally, the gradient of AC, this will give us a -6. That gives us a -8. So they both have a common factor of -2. So divide by -2 is +3 by -2 is +4. And that is our answer, 3 over 4. Moving on to the next question. Okay, and then the next question, we need to find the gradient of line CB. Okay, so they wanted to find AB and then CB. Okay, I guess they're going to ask us whether they are probably perpendicular or not. So we can take that as 0.1 and 0.2. I mean, I'll just take this as 0.1 and then 0.2. Okay, you don't have to write the gradient formula again. You can just say gradient of CB equals and take the y2 minus y1, which is negative 5, minus 3, so minus 5 minus 3, over x2 minus x1, which is 1 minus negative 5. So 1 minus negative 5. Okay, so that will give us a negative 8. That, the negative and negative become a positive, so that's 1 plus 5, which is 6. And you can see how this will just give us negative 4 over 3. Okay, so yeah, you see what those gradients are doing. That is our answer there. Moving on to the next question. Question 3.3, as expected, show that AC is perpendicular to CB. How do you show that lines are perpendicular? Okay, if lines are perpendicular, they intersect at 90 degrees. So that would mean if you take the gradient of this line and you multiply it by the gradient of that line, they will give you negative 1. So let's see. If we take the gradient of AC and you multiply it by the gradient of CB, what do we get? Gradient of AC was 3 over 4. Gradient of CB is negative 4 over 3. And do you see how this perfectly works out? 3 and 3 cancels, 4 and 4 would cancel. And so it's just 1 times negative 1, which is indeed negative 1. Okay, so we can finally conclude. Therefore, we can see the gradient of AC times the gradient of CB really is equal to negative 1. Therefore, AC really is perpendicular to CB. And we have proven that. Okay, so moving on to the next question. The next question, 3.4, says determine the length of the line segment AC. Okay, so find the length of the line AC. And we can just go ahead and call that A and C. I'll take that as 0.1. And we're just going to find the length of that line. Okay, so to find the distance of a line, we simply say the square root of and x2 minus x1 all squared. I mean, you can start with y2 minus y1 all squared. It's fine because you're still adding, okay? And then plus y2 minus y1 all squared. So the distance of AC would be found by taking the x2, which we can see is negative 5, so 0.2, okay, negative 5 minus 3 all squared, plus, and we have 3 minus 9 all squared. Okay, so now just put this in your calculator and get the length of AC, or you can calculate it by yourself, that's also fine. Okay, so this is equal to AC is equal to 10, and I mean, these are all units, so it's just 10 units, and that is our answer. Moving on to the next question. Next question says we need to find the length of line CB. Okay, so CB, since this is B, I'll just take that as 0.1 and that as 0.2. Okay, so to find the length of CB, I'm not going to put down the distance formula because we already have it. So we'll just take x2 minus x1. So this is the second point, x value, minus 5 minus 1 all squared, plus 3 minus negative 5 all squared. And just get the answer on your calculator. And you can see that CB is simply equal to 10 units as well. Okay, so that's clearly an isosceles triangle, okay, a right angle isosceles triangle. And that is our answer. Moving on to the next question. The last question, 3.5, says determine the area of triangle ABC. So to find the area of a triangle, there's a lot we know about this triangle, okay. Remember that we previously were able to prove that AC was perpendicular to BC. So if AC is perpendicular to BC, it means they form 90 degrees over there. And so this is a right-angled triangle. It's also an isosceles. Remember that we already have the length of AC, okay, which is 10 units, and CB. So if AC is 10 units, CB is also 10 units, you see that we have everything we need. To find the area of a triangle, okay, a right-angled triangle, or at least a triangle with a perpendicular height, we can use this as the height of the triangle and then say this is the base of the triangle. So that would mean that to find the area, we'll say a half multiplied by its base multiplied by its perpendicular height. Okay, we have the base, we have the perpendicular height, we have everything we need. So we'll just say the area of this triangle is equal to a half multiplied by that base. I guess we can just name them, it's fine. The base is CB, the height is AC. So multiply by the base of CB, BC, times AC. So it's a half times 10 times 10. 10 times 10 is 100 times a half. Half of 100 is 50. So this is 50 units squared, or 50 square units. And that is our answer. And that is it for question 3. Question 4 says, and yeah, this one is another one that is repeating again. But this is in a June paper. So, great hands, if you check the paper 2, June 2024, okay, if you check at question number 5, question 5.2, you will see this same diagram. It's just inverted. So instead of the line going like this, it goes here instead. Okay, and then, that rhombus is slanted like that. So keep this in mind. They're always going to repeat questions. This question was also from the Gauteng province, just like this one is that we're working on. So you see that a lot of repetition happens. And if you deal with past exam papers, you are somewhat able to predict the type of questions that will come. Or really, if you've just studied all the different types of questions that they have, you will be prepared for anything they bring. If they do, however, introduce something new, it will probably have to do with something that was already there. They just added onto it. Okay, so with this question, they say we have BHSP is a rhombus. The shape is a rhombus whose diagonals intersect at point A. And then they tell us that BA is equal to 8 centimeters. But in that question, the 2024 exam, they gave you the length of the entire diagonal. Okay, still the same thing. Remember, it's a rhombus. The diagonals bisect each other. So this is still the midpoint, meaning BA is equal to AS. Just keep that in mind. Okay, so BA equals 8 centimeters and AP equals 6 centimeters. And then they tell us that the line AC is drawn parallel to BP. Okay, we have these parallel in the diagram below. 4.1 says, write down the size of angle BAP. Okay, it's a June paper, so they have been a bit lenient, okay? But however, in 2024, yeah, they went straight to the point. They didn't ask you to find the angle and then score you 2 marks for that. They didn't do that, okay? They went straight to the point of asking you to find the length of a certain side. Okay, so with this one, what we're going to do is look at that angle. It says BAP, right? So from B to A to P is this angle over here. They want us to tell them that angle. What do you know about the diagonals of a rhombus? The diagonals of a rhombus, they don't only bisect, they bisect at 90 degrees. Okay, so all of these angles here at the center, they are equal to 90 degrees. So we can see that. Of course, you have to give reasons here. It's Euclid. So we will say BAP equals 90 degrees and then tell them the reason. This is because the diagonals of a rhombus bisect at 90 degrees. Okay, and that is our answer. Moving on to the next question. And then there is that question 4.2, calculate the length of BP. Okay, so in the 2024 paper, they just went straight to that, asked for that length. Okay, and then they scored 4 marks for that. So this BP, how do you find the length of it if you know this is 90 degrees? Well, do you see now that this has created a right angle triangle? That's what we have here. And what is missing is the side right opposite that right angle. So the hypotenuse is missing. So to find BP, you'd say BP squared, okay, is equal to AB squared plus AP squared. And this is because of the theorem of Pythagoras, okay? That hypotenuse squared equals shorter side squared plus other shorter side squared. Okay, so for our reason, we say Pythagoras. And now let's find BP squared. So this is going to be equal to AB squared, which is 8. So 8 squared plus 6 squared. And let's find this. So this is 64 plus 36, which gives us 100. And so BP squared is equal to 100 and then square root both hand sides. You don't have to consider the negative here because we are working with lengths. So BP equals 10 and we are working with centimeters. Okay, so 10 centimeters. And that is our answer. Moving on to the next question. And then question 4.3 says write down the length of AC. Let's look at AC. So currently what we found was BP, which is 10 centimeters. If this is 10 centimeters, how do you find AC? Okay, you see AC is that one parallel line. And look at what they are creating here. Okay, they are creating, you should spot a specific theorem here. Look at that. That's a triangle. And then you have a line drawn parallel to one side of the triangle. So which theorem are they using here? They're using the midpoint theorem. Okay. Remember how these diagonals work. This diagonal, BS, it bisects this diagonal. So it cuts that diagonal into two equal parts, meaning this is equal to this. But then HP also bisects BS. Remember, to bisect means to cut into two equal parts, meaning this side, AB, is equal to AS. And we need to state that first. And the reason we're doing this is because now we can use the midpoint theorem. So you need to know the difference between the midpoint theorem and the converse of the midpoint theorem. And here is an explanation of that. Okay, so with theorems, and even with this particular theorem, the main thing that differentiates theorems is what have you been given and what do you have to conclude with what you have been given. So it's the same thing with the midpoint theorem and the converse. With the midpoint theorem, it depends on what you have been given. So the actual midpoint theorem, you have to be given the following. If you are told that AD is equal to DB and AE is equal to EC, what you would then conclude from this is that BC, you see this BC, it is equal to double the size of DE, okay, to DE. And another thing you would conclude is that you see DE and BC, they are actually parallel lines. And to keep it simple, you can simply just say your reason is the midpoint theorem, and then that would be it. Okay, and that's how the midpoint theorem works. Now, when we look at the converse of the midpoint theorem, you have to pay special attention to what has been given or what you have found so long in this triangle. So, with the converse of the midpoint theorem, what they would tell you is something like this. They could give you that AD is equal to DB, right? Okay, so we know that AD equals DB. And then they could also tell you that DE is already parallel to BC. Okay, now from this, what would you conclude? Your conclusion would be, okay, if you give me this, then it means that AE is actually equal to EC and BC is twice the size of DE. That would be your conclusion. And so because of this, your conclusion would be the converse of the midpoint theorem. Okay, so that is the difference between the midpoint theorem and its converse. Okay, so with that being said, let's go ahead and tell them that these two are equal. So we'll tell them that AS is equal to AB, which is equal to 8 centimeters. Okay, so AS equals AB, and therefore AS is actually equal to 8 centimeters. And the reason for this is because the diagonals of a rhombus bisect each other. Of course, they bisect at 90 degrees, but I'm not really bothered about the 90-degree part. I just want to say that they bisect, okay, each other. And then now that we know that we have these two being equal, remember from the explanation of the midpoint theorem, in this case, look at what we have been given, or what we have currently. We have that AS is already equal to AB, and we have that AC is parallel to BP. So in this case, we are going to use the converse of the midpoint theorem because of what we have been given, or what we have. So let's just state the things we have. We have already said that these two are equal. And then let's just also state that these lines are parallel. So I'm going to remind them that I know that AC is parallel to BP. So AC is also parallel to BP. And this was given. I'm just trying to state these two things first, that these are equal and these two lines are parallel. We can therefore conclude that SC or CS is equal to CP, which is not really necessary right now. Because of that, what we can conclude is BP is twice the length of AC. Okay, or you can also say AC is half the length of BP. So whichever way you say it, it still works. We can say AC is equal to half the length of BP, and you know that BP is 10 centimeters. So AC is equal to half of 10, which is equal to 5 centimeters. And the reason for this would be the converse of the midpoint theorem. And that is our answer for AC. Moving on to the next question. Question 4.4, again, this is also a question that was asked in the 2024 exam. Determine the area of quadrilateral BHSP. Okay, so we want the area of this quad that we have. This quad is a rhombus, but do you see how it is made up of two triangles? Okay, we have this triangle over here and we have this triangle over here, but we have to use useful triangles. So to find the area of a triangle, we saw in analytical geometry, okay, that it is a half multiplied by the base multiplied by the perpendicular height. So can we spot a base and a perpendicular height here? We can, okay, we can use this triangle over here, right? And what is the base of the triangle? If you know this is 8 and this is 8, the base is 16, okay, 16 centimeters. And then what is the perpendicular height? That would be the height that is perpendicular to the base. Do you see that from P? Okay, we can see that as the highest point of the triangle to the base. Do you see that? It is perpendicular. So this is our height, which is 6 centimeters. So that's one triangle we can see. And then the other triangle that completes this rhombus would be this one. Do you see how we know that this is equal to this? We just have to state it. So this would serve as the height of the triangle. And then again, this is the base of the triangle because it's perpendicular to that height, okay? Because the height is perpendicular to the base. Okay, so that's what we're going to do. Use these two triangles. So I'm first just going to state that I know these two are equal because the diagonals of a rhombus bisect each other. So AH is equal to AP, which is equal to 6 centimeters. Okay, so say therefore AH equals 6 centimeters. And the reason is because we know that the diagonals of a rhombus bisect each other. And then finally, let's work with that area. So to find the area of this quad, okay, is BHSP, we will simply say the area of this triangle, okay, these two triangles. So the first triangle is this triangle HBS, and then plus the area of the second triangle that we have there on the bottom, and that is triangle BPS. Okay, so the area of that first triangle, and you can see that those triangles are exactly the same. They have the same base, the same height. So just say a half multiplied by your base, which we can see the base is 16 units because that's also 8 centimeters. So 16 centimeters and then multiplied by the perpendicular height. They both have a perpendicular height of 6 centimeters. So all of this, because you're just going to add by the same thing, you can just say it's double of this. So it's going to be times 2. So 2 times all of this, which is equal to, and we have 2. Okay, so then a half times 16 is 8. 8 times 6 is 48. And then 48, and then times 2 is 96. So 96 centimeters squared is our area. And that is the area of that quad. And that is it for question 4. Okay, so that is the last question for this paper. And that is it for this paper. I hope you guys enjoyed it, and I'm wishing you everything of the best for your June exams. See you in the future videos.